Hello everyone, this is Ryan, third year PhD student at Computer Science Department. I'm going to present my codebook on corticomuscular coherence. This codebook will contain the data of a clinical study in bilateral cerebral palsy. So the data driven from this codebook is CMC. So what is CMC? CMC is an index of coherence between brain motor cortex and associated body muscles. It indicates linear connection between two signals. So this codebook will contain the data of CMC between EEG and EMG sensor. So this is the study conducted at PMNL lab. The pedaling there was 4 pedaling tasks. We collected data of 20 channels start-time EEG system, and we collected data from 10 muscle surface position on both hand, left and right hand. So this is the codebook of our CMC. So you can see this is the participants data, the variables. Here is actually contain the data of demographic and medical condition of a participant. So it's contain the unique participant ID, age, sex, height, weight, ethnicity, race, country, zip code, language, education level, gestational age, and hemiparesis condition. There is 3 condition we actually collected. So it's the left hemiparesis, right hemiparesis, or no hemiparesis. Then is there any previous seizure condition, or what is the current medication, or is there any other medical condition of this participant. So this is the pedaling data. So it's actually the data of each trial. So each trial, a session have multiple trials, but it contains the data of each trial. So it's the trial date, the trial duration, then the trial condition, as we have 4 type of tasks. So there is 4 condition. Then data slice duration. So we actually chunk the data into small chunk, small slice for calculating the CMC. So as example, if the data has like 60-second record in each trial, then we'll slice the data in 2 seconds or 3 seconds for calculating the CMC. And there is a start time and end time of the data slicing, and some pedaling variables. It will contain the mean and standard deviation of count revolution per epoch, then left hand velocity, right hand velocity. So here you can see the variables of EEG data. So it's contain the mean and standard deviation of 20 channels data that actually measured in microvolt, and it's all of this data are longitudinal. So this is the EMG data. So it's also contain the mean and standard deviation of each EMG surface sensor of 10 location. So this is the CMC calculation value. You can see CMC actually calculate between 2 signals. So there will be 2 channel, like EEG channel and EMG channel, and what method actually used for calculating the CMC. And this is the frequency in hertz that actually calculate as you calculate this in a frequency domain. So it will store the which frequency associated with a CMC value, and frequency band is the categorize the frequency in different band, is delta, theta, or alpha. Then CMC value calculate using the specific method, and CMC category is a categorical value that actually calculate based on the CMC value. So it's like there will be a high correlation between 2 signal. That means CMC is greater than 85%, or there's no correlation between 2 signal. That means CMC is less than 70%. So why this CMC data bank is important? So CMC observation data points are huge and difficult to analyze using the traditional method. We can estimate the CMC data point. Let's consider we have 30 participant data and each participant has 12 trials. Then there will be total 360 trials and each trial length is 60 seconds. Then the total data record is almost 21,000 seconds. And if we observe the CNC in 2-second duration, and there is a 20 electrode EEG electrode and 10 EMG sensor channel, and we observe the frequency from 1 to 40, then total record will be 8.64 million. This is huge, so that's why we need advanced technique for analyze this data. Thank you so much.